Hello and welcome to today's lesson on solution of first order ordinary differential equation by method of separating variables. In order not to miss any video, kindly subscribe to my channel and hit on the notification button. Now, let us consider equation of the form dy over dx equal to f of x times f of y, and the second one is dy over dx equal to f of x over f of y. Now, we observe that in these two equations, the right hand side for the first one is written as the product of two functions x and y, while the right hand side of the second function is written as a quotient of two functions x and y, in such a manner that it is easy to write one function on one side on either side of the equation. For example, we are able to write f of x on either the left hand side and f of y on the right hand side of the equation. So when we are able to write an equation in that manner, then we say that we are solving the first order ODE here by method of what? Separating variables. So in other words, the method simply entails being able to write one of these variables on either side of our equation. Without wasting so much time, let us go straight to an example to illustrate the method. So we have solve y prime equal x squared over y subject to y of 0 equal to minus 5. Of course, y of 0 equals to minus 5 is called the initial condition, and so this problem is called an initial value problem, where the value of x at 0 is already given. So we proceed by solving with method of separating variables. We have y prime equal to x squared over y. We can write y prime as what? As dy over dx equal to x squared over y. We observe that the right hand side of this problem is given as a quotient of two functions x and y. So it is possible to separate the variables by writing either y or x on either side of the equation as follows. If we cross multiply at this point, what do we get? We get that y times dy is equal to x squared times dx. And by doing this, we observe that the variable y is on the left hand side of the equation, while the variable x is on the right hand side of the equation. So the variables have just been separated. Now we proceed to find the value, or to find the solution to this first order differential equation. So to get the value for y, what do? We integrate both sides. So we integrate the left hand side with respect to y and integrate the right hand side with respect to what? X. So if we integrate y with respect to y, we get y squared over 2. And if we integrate x squared with respect to x, we get x cubed over 3. Since we are done with our integration, we introduce our constant of integration, what? C. So to make y the sort of formula, we proceed as follows again. If we multiply through each term by 2, what do we get? If we multiply y squared over 2 by 2, we get y squared equal to, multiply this term by 2, we get 2 over 3 x cubed, plus multiply c by 2, we get 2c. So we can just write what we have as y squared equal to 2 over 3 x cubed plus, say, c naught. Because c is a constant, and if I multiply a constant by 2, I still get a constant. So I want to now call the new constant c naught. So to get y, we say, okay, so y is equal to plus or minus the square root of 2 over 3 x cubed plus c naught. So this is our solution to the first order ordinary differential equation given here. So we are given the initial condition that what? That y of 0 equal to minus what? 5. So we shall use this initial condition to get the value of the unknown constant C naught. So this means that when x is 0, that y is what? -5. So we come here and put the value of y as -5 and x as 0. So that becomes, when y is -5 equal to, for the first value plus equal to 2/3 x is 0, so 0 cubed plus C naught. So that gives us -5 equal to, this is 0, the square root of what? C naught. So that C naught is equal to -5 raised to the power 2 equal to what? 25. So the value of the constant C naught is nothing but what? 25. If we take the second part, which is the minus part, what do we get? We get -5 equal to minus the square root of what? C naught again. So that minus and minus will cancel, and we have that 5 is equal to the square root of what? C naught. Then C naught again is the square of 5, which is what? 25. So in either case, the value of our C naught constant is nothing but what? 25. Now that we have the value of C naught as 25, we can now write the particular solution to this problem as what? This becomes y equal to plus or minus the square root of 2/3 x cubed plus, our C naught is now 25. Our C naught is now 25. Of course, we can just write this as, and that is it. And this becomes the particular solution to the first order ordinary differential equation. We have just solved this equation by method of separating variable.